So the last step we're going to be kind of looking at is if we add 60 milliliters of sodium hydroxide to our 50 milliliters of HF. And so one thing you should notice here is if the last step was the equivalence point, that means this step, which is above that volume of sodium hydroxide, now we're passing over that neutral area, and now we're looking at more base than we looking at than acid we had available. And so here we need to figure out how much hydroxide was actually added and figure out how much of that hydroxide was reacted to figure out how much hydroxide is going to be in excess. And so here, using the 60 milliliters of our sodium hydroxide and the 0.5 molarity sodium hydroxide, I can tell you that I have 0.3 or 0.3 moles of hydroxide ions that are being added. But again, some of those hydroxide ions are going to react with the acid to produce water in the conjugate base. But because we have an excess of our hydroxide ions, some of those bad boys are not going to react. And so here we need to figure out that 0.03 moles of our hydroxide ions is the total moles that are added. But only 0.025 moles of those hydroxide ions are actually going to react because that's all the HF we have. After all of the HF has reacted, then again, some of those hydroxide ions are going to be floating around by themselves without anything else to react with. And so here, we solve for the concentration of our hydroxide ions is 0.045 molarity. And so using the concept of water again, we know that the Kw is going to be equal to your hydroxide ions of your hydronium, or you can rewrite this again as your Kw is going to be equal, if Kw is equal to your the hydroxide ions. So your hydroxide ions is equal to Kw over your hydroxide ion. Sorry, my daughter's knocking on the door trying to tell her to go away. And so you have Kw is equal to 10 to the negative 14 over the concentration of our hydroxide ions of 0.045. You end up with a hydronium concentration of 2.2 times 10 to the negative 13. So once we know the hydronium concentrations, we can solve for the pH using the same steps we've done before. pH equals the negative log of our hydronium ion of 2.2 times 10 to the negative 13 to give you 12.65. So this is all the steps you need to take. I know it seems like a lot of math, but if you kind of go back and look at all of it, it's all the same exact math. Use whatever information you're given to somehow solve for your hydronium concentration. Once you know that, solve for pH. As I've kind of shown in previous videos and everything, there's more than one way to kind of go about these problems. For instance, you can solve from your hydroxide concentration. You can solve for POH and then use the POH to solve for pH. All of it should hopefully lead to the same answer.